Good afternoon, everybody. I'm happy to be here. We'll start with the first slide here. I got to stay scripted because we only have 20 minutes, and I know you want to get the coffee break. Using FORSEE and continuous forest inventory information to compare volume estimation methods in Santa Cruz Coast Redwood forests. You see my co-authors there, and I want to introduce to you Mitch Hayden, partner and staff forester with ERS, Environmental Resource Solutions, and Mr. Steve Otten. Steve Otten is our resource manager. I can't resist being a professor emeritus now and for 30 years teaching. These two young men were my students so many years ago, and they're very successful professionals today. So I speak with a lot of honor, a lot of humility today, because it's nice to have my students standing here with me today making this presentation. We've dedicated this paper to two people. Obviously, Mr. Al Smith, our benefactor for Swamp Pacific Ranch, and recently in 2016, April, Dale Holderman passed away, and he's Mr. Selection Forestry in our county, and obviously he had an impact on all of us as we were trying to debate the right way to do selection forestry, and so those two men are very important to us. In terms of acknowledgement, we thank the McIntyre Stennis Program for funding support. We had two different grants for that. ERS, Bonnie Birchall and the staff for what they did to support this work. Dr. Bruce Crumland, we did some volume equation development, and obviously we had to turn to Bruce in relationship to FORSEE. Janet Webb and Big Creek Lumber Company and the McCrary family. Nadia Hamey, she walks on water as far as I'm concerned in terms of her ability as a RPF and consulting forester. Dr. Brian Dietrich and the staff at Cal Poly Swamp Pacific Ranch. Many Cal Poly students, faculty and staff, various people and organizations and agencies for advancing Cal Poly's Learn by Doing forest management and environmental stewardship work at our school forest, which includes the Valencia track. There's an old adage as I start this introduction here, and by the way, Mitch and Steve are going to be helping me with the presentation. When it comes to modeling, garbage in, garbage out. In 2012, we did a paper, presented it at the 2012 Coast Redwood Symposium on our Little Creek CFI study, and it definitely demonstrated the impact of the Lockheed fire. It demonstrated all the impact of entries of selection forestry and the development of an uneven age stand, and what happens to an uneven age stand when a fire comes along. But we were over projecting volume, we thought, with reference to the FORSEE model. And we needed to think about why that was happening. And we knew that we had a very solid database at Valencia, so we went to Valencia to try this study. And now there's four possible reasons why volume might be over-projected. Highly varied stand conditions, which Little Creek did have, access data processing and auditing errors, incomplete knowledge on how to run FORSEE, or perhaps there's something to do with the volume equations and the professional judgments you need to make in relationship to the right volume equation. And so it's in that context that we initiated the Valencia study. Now, there's a lot of research out there, and obviously I could fill 40 pages of a PowerPoint presentation. But I'd like to point out that in '96 we gave the first paper about how we're implementing uneven age management on our school forest. In 2012, we reported on the Little Creek study, and today now we're going to report on the Valencia study, which sheds much more light on how to go about establishing an uneven age stand, how to monitor it, and how FORSEE works in relationship to projecting all of that. Just a little bit of historical context. We're near Davenport, Santa Cruz County. We're in the southern sub-district, the Coast District. We practice uneven age management and selection forestry. We don't have a choice. The forest practice rules specify nothing larger than a half an acre in size. There are tree removal limits by diameter class. There are very strict WILPAS requirements, and there's additional requirements as well. Cal Poly and Big Creek Lumber Company were very much involved in establishing a NTMP. We did the first one in 2001. The second amendment, as time goes on, you always have to make some adjustments. We did in 2013. Nadia Hamey, Steve Otten were involved with the second one, and you can see Joe Culver, myself, and Wally Mark did the first one. Now, this is important. I need to say this, and I don't want to bog down here, but uneven age management, in my opinion, needs to be well thought out, and you need to establish targets. They need to be flexible targets given the variable nature of coast redwood stands. I started out by calling it Golden's BDQ approach, but it quickly evolved given the variability of redwood stands to a modified BDQ approach because I like holding on to the larger trees. I like holding on to trees larger than the maximum diameter. I have a bias that way in relationship to high grading, in relationship to wildlife variety that you're trying to create in that landscape, in relationship to carrying inventory, and maybe you might just be promoting growth. And so it's in that context that the marking rules were established for both our Little Creek units and our Valencia units. Now, in terms of harvest entries, 2001 and 2 were our first entry as we took over the property, and you see again in 2013 and 14. We've harvested about 8 million gross volume over those two entries, and we've brought in $3.2 million. Understand this is a working forest, and understand this is a management observational study. Now, the objectives of the study were to standardize our 2001, 2002, and 2012 inventory data using FORSEE, and to then upload that into the FORSEE for inventory analysis and comparison utilizing various tree volume equations, and to model. We grew the stand from 2001 to 2012, and we actually compared it to our 2012 inventory. We used a variety of volume equations in this whole process. And ultimately, this whole study was, are we doing what we're saying we're doing in relationship to implementing uneven age management, and are we achieving sustainability? Now, our methods, I'm going to turn this over to Steve.
Good afternoon, everyone. Steve Otten, Operations Manager, Cal Poly Swanton Ranch. Doug, it has been a pleasure working and learning from you all these years, too, by the way, too. So thanks for that. And welcome to the southern range of redwoods. I know we've been talking a lot about the north, and I think that statement really ties in a lot to the CFI system. The CFI system, standing right for continuous forest inventory, was installed prior to our non-industrial timber management plan. So it's what we had to work with. And as most of you know, CFI plots with a fixed fifth acre point with a radius of 52.6. We measure all the trees down to 1 inch in diameter. It has some similarities to Blodgett Research Forest. And now UCSC has also taken on this methodology in Santa Cruz, and they're starting to develop a CFI system that's closely related to ours too. And but they're really detailed. They're expensive to put in. The 82 that we have at Valencia also involve downed woody debris. They also involve herbaceous vegetative ground cover, and pretty lengthy. And in addition with that too, the whole total, we have 256 of them between the two properties. So when we think about their utilization, they are initially located with a baseline and benchmark, class 1 level survey, and then early on we used to break off with the staff compass and head out into the woods from there. So there's kind of our general overview of some of the baseline activities associated with the CFI part, but so ultimately what happened was the data that came from the CFIs was handed off to Mitch, which we're going to get to in just a second, to develop into growth and yield predictions, which was also used for a non-industrial timber management update for our entries, because that's the way they're structured. They essentially say, before you guys enter each time, you guys are going to remeasure the CFI and see what happened and figure out what your growth rate is and go from there. So this kind of gives you the acres breakdown, and we'll just go with the totals at 591, and the acres that were analyzed were 563 for the whole Valencia tract, and this one has kind of washed out a little bit, but you can kind of see that line that's in between the two properties. There's a unit 1 and a unit 2, and maybe this will show up a little bit better. But when we went back in for the NTMP amendment, we spent a lot more time on stratification, knowing that we had a 2 to 3% sample, and that ultimately recognizing that most of the stuff that's kind of, I'm just going to walk out of this area right through here, and you can see some of the brush areas in Douglas fir and some of the types. There was a high degree of homogeneity across the property, which really helped out ultimately with the level of statistics and standard error. So on top of that, too, there was, at the same time, Rich Thompson was doing a paper on carbon stocks on the same property and did a variable plot sample with 173 plots out here, and ultimately came up with a volume that was right smack dab in the middle of what the CFI volumes were, and standard errors in the VPS sample was approximately 5.7, and I think Mitch will mention this, but around 12% for the Redwood type in this study. So that's sort of the basis of the systematic random sampling system, CFI with 82 plots on it, and that data was where it was gathered and then handed off to Mitch. And I think you have the next slide. Thanks, Mitch.
So thank you. I'm Mitch Hayden with Environmental Resource Solutions. So when Doug originally contacted me at a CLFA conference, he said, oh, I've got a data set I want to run for volume and see how the growth compares. And then he added 5 more volume equations to the list and wanted to do the whole study with all of that. So we used Wenzel and Crumlin Bulletin, 1907. We have a senior project, the Lent equation, used 70 trees, redwoods, from a fallen buck study from Valencia. We used the Lindquist and Pally Spalding volume table, Bulletin 796. Ben Hahn's master thesis, which is still in progress, he developed 2 volume equations from 104 fallen buck study trees from Valencia. For hardwood, we used the Pillsbury Pacific Northwest 414, and all of these models were set up for a 6-inch top diameter inside bark, except the Spalding model, which was the basis of the original table, which was 8 inches. So here are the general model equations and the coefficients for all of those models. Those are available on request. And what did we actually find out? This is the 2001 data. You can see for all conifers, we have a basal area of about 208 square feet, total of about 296 for the stand. We also ran the carbon modeling in FORSEE, so you can see the baseline measurement there. And then down in the bottom half are all of the equations that we ran for this study, the Bolton 1907, the taper equation, the Millant local, the Spalding, and the 2 Masters equations. We have a range in here of volumes from 33,000 board feet per acre for the entire unit. This is the entire 560 acres modeled, and it spreads to 40,000. The stand graph, generally uneven age graph. Let's see here. And then in 2002, the data was gone through and field checked, and they removed all of the harvest trees from the unit. And so the harvest resulted in a basal area reduction of 46 square feet per acre and approximately 8,800 board feet per acre. You can't really tell in the graph, especially with the scale change on the left-hand side, but it looks very similar. This graph, unfortunately, is washed out. This is a comparison of the pre- and post-harvest trees per acre, and I don't think that I can change the grade out, which you can't see. On the side monitor, you may be able to see a slight reduction in post-harvest number of trees per acre. Then we took that data set, the 2002 post-harvest, and we grew it up to 2012 with no ingrowth, and it resulted in a conifer basal area of 190 square feet. If you remember, we started out at for conifer was 208 where we started. FORSEE grew it up to 190 square feet. And we have the volumes here. I'll talk about that in a little bit. This is what the stand looked like post-harvest and grow into 2012, I'm sorry. And again, if you look on the side monitor, you'll actually see this is the post-harvest grown to 2012, the DBH classes advancing. And this is the actual 2012 stocking metrics, whereas FORSEE grew this stand up to, for conifers, 190 square feet. The actual measurement was just right about 207, which is almost exactly where this stand started in 2001. There is the current data set. And again, this graph is washed out. I'm sorry, if you look on the side monitor, you can actually see one of the main results is we compared individual tree record, both DBH and height growth. And in the trees, in the 14 and lower inch size class, FORSEE seemed to be overestimating the diameter growth. And in the trees generally 24 inches and larger, it seemed to be underestimating the diameter growth of those records. The results of the volume equation study resulted in a ranking order of highest to lowest. The Bulletin 1907 equation is undoubtedly at the top. In conversation with Bruce Crumlin, it was noted that his original data set was limited and included very few trees over 48 inches. And his assessment is that the Bulletin 1907 equation overestimates volume in the larger size classes. Overestimates, I hope that's what I said. The taper equations are generally the, kind of now accepted as the best estimator of volume, publicly available volume equations. We had Bruce convert the Lindquist and Pally 796 table, the Spalding rule table, to a model form that would be compatible with FORSEE. We wanted to see where that one fell on the list. And it's at the lower end of the publicly available tables. Masters 7, 6, and the Lent local are from the Fallen Buck study. And they all came in up to 20% below basically this taper equation, consistent with what we kind of expected. Here was the stand volume change over time. So we have the pre-harvest, post-harvest, FORSEE growing to 2012, and the actual growing to 2012. Similar changes in basal area, where FORSEE was slightly underestimating it. Change in QMD, FORSEE slightly overestimated the change. And in trees per acre, one of the assumptions in the model was that we were not going to add ingrowth to the growing to 2012, and you can see that expressed here in no change in the trees per acre. So Doug, did you want to come up and talk about the overall conclusions?
Okay, just summarizing now. FORSEE underestimated conifer basal area per acre growth. It overestimated change in quadratic mean diameter. It overestimated growth potential of smaller trees less than 12 inches, as Mitch said. Underestimated growth potential of larger trees greater than 13 inches. Underestimated volume by as much as 16.3%. Our CFI data, now this is huge, the second bullet point, tells us that by 2012, stand volume growth completely recovered from harvest and exceeded pre-harvest 2001 gross volume by almost 10%. And look at that growth figure. You know, most people are happy if they can get 500 to 700 board feet. We're achieving an average stand growth of 1,266 board feet per acre per year, or about 3%. As Mitch has indicated, with Dr. Bruce Crumlin's consultation, it looks like the Spalding rule is best for us, and that modified BDQ targets were met on both entries, leading to an uneven age stand structure. So that leads us to these conclusions. Number one, FORSEE is a useful inventory growth and yield model. But I'll just say that it requires judgment on the part of the forester in terms of making adjustments to it in relationship to your specific property. The modified BDQ approach is sustainable, and that's evident by the data we presented today. That varying the cutting prescription across your property is a good idea, and intensity of cut to conditions between and within stands. In my opinion, based on the data that I'm presenting to you, it's not wise to cut all your largest trees, for all the reasons I said earlier, and as I'm tending to indicate there. And when you go into selection forestry, you're going in every 10 to 15 years. You've got to realize you're not going to correct all the problems on the first entry, or even the second entry. The next two conclusions: intensity of selection cutting can vary in relationship to promoting development and growth of smaller trees as you're working your way across the unit. And as my students and I are looking up at the redwoods, the wonder of all forest types, Coast Redwood. Thank you, ladies and gentlemen.
The site trees are really important in FORSEE, and it's hard to get a good site tree in a selection harvest. How did you do a site tree at each CFI plot, and how much effort did you put into reliable site testing?
Well, it's kind of tough because it's been selected before. So there were site tree estimates out there that we're taking there at CFI, but kind of marginal, and I don't think we ever have been or handle on which.
As Crumlin has talked about how much effort we ought to be spending on estimating site tree, because it makes a huge difference on estimates.
Yeah, I think the site tree that we have came out with an average redwood siting of 89 on this study. And I think that if you were to make some adjustments or a sensitivity analysis to cite that, you might see some of those variables changing there.
I think one other important thing to add too, when you look at that 1266 growth rate out there too, I think that's definitely something we should think about a little bit more, because it's a pretty high growth rate, right? 1266, everybody's like, wow. And I think it's a function of adding volume to larger trees, right? Because we have a function of the equation, how we calculate the volume by R squared, right? We square the radius. And when you do that, when you're adding wood on a larger diameter trees, it's an exponential growth in volume. So whereas, when you think about the rangeland, right? Look at the rangeland, it's like, oh, there's a cow per acre production. Maybe we also need to think about the cubic volume per acre production. What's that block of wood look like? Or slicing up and adding to larger or smaller trees that remain behind. So I think you can see it flux a lot in the overall volume. If we go to measure CFI next time, it'll be different.
I think this is a pretty important study. Things like this with a large acreage, where you're tracking and you're projecting the FORSEE and you're comparing that to real data from different mission periods. A lot of value here. I'm quite happy to share that data with you. Help us better understand how to better manage those things. Selection forestry can work with your big trees working with forestry.
Because I'm wondering if you know of similar studies done in even age stands. Presumably FORSEE was developed with that in mind, and uneven age is a bit of a stretch. How you were only off by a relatively small percentage, 16%, using FORSEE to project uneven age stands. Do that much better even age stands?
Focus on this and all.
I haven't done studies, yeah.
I'm going to talk to you when we talk to groups about it. I'll ask them.
The same to replicate your study more or less an even age stand, that's closer.
Well, thank you, everybody. Enjoy your coffee break.